Hi, this is Alex from devstories.eu. DeepEval Framework, episode 15 of 18. Your LLM might answer every normal question perfectly, but what happens when a malicious user actively tries to jailbreak your application into leaking sensitive data? That requires a completely different approach, which brings us to an introduction to red teaming. To understand red teaming, you have to change how you view your system. Standard evaluation tests functionality. It measures if your model is helpful, accurate, and relevant when used properly. Red teaming tests security, safety, and guardrails. It requires a mindset shift from checking for correctness to simulating malicious bad actors. You are actively trying to make the model fail. Take a common scenario. If you directly ask your AI application to output a user profile, standard guardrails will likely catch it. The AI strictly refuses to leak the personal identifiable information, or PII. A standard evaluation marks this as a success. But a bad actor will not ask directly. They might prompt the model using a specific malicious persona, instructing the AI to act as a senior database administrator performing an emergency system override. Suddenly, the AI complies and willingly leaks the PII. Red teaming is the systematic process of discovering these exact blind spots before they reach production. DeepEval structures this process around 4 core components. The first component is vulnerabilities. A vulnerability is the specific weakness, risk, or harm you are testing for. It is the underlying issue you want to prevent. In our emergency override scenario, the vulnerability is PII leakage. Other vulnerabilities might include generating toxic output, displaying unauthorized bias, or offering dangerous advice. The second component is adversarial attacks. If the vulnerability is the target, the attack is the weapon. Attacks are the specific techniques or means used to exploit a vulnerability. Adopting a trusted persona to trick the AI is one type of attack. Others include prompt injection, where malicious instructions are hidden in regular input, or complex jailbreaks designed to bypass the model's safety training entirely. DeepEval separates the weakness from the tactic because a single vulnerability can be exposed by many different types of attacks. The third component is the target LLM system. This is the actual application you are evaluating. It is not just the raw foundation model, but your specific architecture. This includes your custom system prompts, your retrieval mechanisms, and any existing safety filters. The adversarial attacks are executed directly against this setup to see how your actual product performs under pressure. The fourth component is metrics. Once an attack is executed against your target system to probe for a vulnerability, you need a quantifiable result. Metrics evaluate the system's response. They determine if the attack successfully bypassed the guardrails or if the system safely refused the malicious request. A metric scores the interaction, giving you a concrete pass or fail based on how secure the output actually was. Here is the key insight. You cannot secure an AI application just by proving it does the right thing when asked nicely. You must systematically prove it refuses to do the wrong thing when under attack. Thanks for listening. Happy coding, everyone.